This is the last in a series of videos in which I'm repairing this HH Tiger computer. If you've watched the previous videos, then you'll know that I fixed a fault with the power supply, replaced quite a number of failed ICs, and the system is now pretty much up and running. We'll have a look at the monitor in a few minutes. What I like to do with old machines like this, especially rare ones like this, and there are very few of these made, just a handful, I like to go through the circuitry and see how it was designed and try to figure out the thinking behind the design. And it's surprising how many different approaches there were at the time, especially in these 1980s machines. And this is no exception. This is a fairly unusual machine. It's got two main microprocessors and a third processor in the form of the video controller chip. And the way they interact is quite interesting. I've spent some time now since it's been up and running looking at the way it behaves and the way it works, and it is quite interesting. There are some very peculiar aspects to its design. I think I've touched on a couple of those previously, and there's one in particular that I'll look at in a few minutes with regard to the keyboard. But fundamentally it's now working, so we'll have a quick look at the monitor. I can't get too far with this because I don't have the real monitor and I don't have a floppy drive to run the operating system. But we'll have a quick look at the monitor and you can see how far it gets in its current state. Okay, so I'll boot the machine up and you can see it's now coming to life as it should. It's saying the configuration needs restoring, presumably because the CMOS contents have been lost. I will refit the battery when I fit the board to the case. But now it's asking for a disk in drive A. I don't have the disk, I don't even have the drive, so I can't really do much. It is responding to the keyboard. As you can see, it's responding to the key, but it's still trying to boot from the drive. If I press the return key, you can see we get the CPM version 2.2 prompt, and I think it's just now looking for the floppy drive to boot from. So that's as far as I can really go with this machine. I'll now start putting it all back together again. The display doesn't look too good simply because I'm still passing this through the composite converter circuit I made. I'm doing that because the output for the video is a little bit unusual and I didn't really want to go to all the trouble of building an interface circuit to suit this particular monitor. All the outputs are working. There seem to be 4 outputs in total, one for the sync and composite, and then one for each of 3 channels, but the 3 channels seem to be doing different things depending on whether it's in text or graphics mode. And I'm assuming that's all taken care of by the monitor that is for this particular machine, but it would be very easy to make an interface, but this is not my machine, so I'm not going to go to the time and trouble of doing that. I have tested all the outputs though, and they do all seem to be working. What we'll do now is have a look at the keyboard. As I said, there's a fairly unusual feature that I found in it that is probably worth mentioning. So we're looking at the corner of the keyboard. Anyone not familiar with the way these keyboards work, they're very straightforward. They just consist of a series of keys that are arranged in a matrix, and the system detects which key is being pressed by scanning through rows of keys. It energizes one row at a time, and then on the output side there are multiplexers or something similar that detect when a key in a particular row is being pressed, and so the system knows which key is being pressed because it knows which column it's currently energizing, and then depending on which output from the multiplexer is showing a signal, it knows which particular key is being depressed. This keyboard works the same way, and it drives the keys in banks, and that means that the inputs to the buffers are common, so they're in a couple of banks, and that is across a couple of chips as well, so the inputs are common across a couple of the buffers. So there are 3 buffer chips, 3 multiplexers, and they work together to drive the rows and detect the column that's being energized or active. Now this keyboard shouldn't actually work. As I say, I found something very strange with this when I was going through the circuit, and I'll just demonstrate what that is. If I connect my probe to the plus supply on the main board, As I say, this machine's turned off at the moment. And then if I check the power pin on this IC, and it's connected to 5 volts. And the same with this one. You can see this, my hands aren't completely in the way. But if I check one of these devices, you can see it's not connected to the supply. This one is connected to 5 volts. Get my probe on. And so is this one, but this one isn't, and neither is this one. And they're not connected together either. In fact, they're not connected to anything. These power pins on these two devices are not connected to anything at all. They're not connected to each other, they're not connected to ground, they're not connected through a resistor. There is no connection going to these power pins at all. At first I thought they were maybe redundant devices that weren't doing anything, but looking at the circuit I realised that these are in fact needed for the keyboard to work. And I couldn't at first figure out what was going on. Now, this is just a fortuitous happenstance that this actually works at all. It's being fed, the inputs to these two devices, as I say, are common, and that's one of the only reasons this works. And they're being fed from an output of the PIA, which can drive several milliamps, and that again is part of the reason this works. If we look at the voltages on here, so I'll power the machine up. Okay, so the machine is now on. If we look at the voltage on one of the power pins that we know is connected to 5 volts, then we can see it's 4.9 volts. But if we look at the power pin on one of the devices we know is not connected, we can see it's 4.4 volts, about half a volt less. And that gives us a clue as to what's actually going on here. If we look at the spec sheet for that particular buffer, then it has a representative circuit of the way this is arranged. And what we can see is there are some protection diodes on the input to each gate. And these are what are actually feeding power to the device. So internally within the chip, this is connected to the power pin. So when we feed an input to the gate, then this goes high. And of course through the diode it drives power or supplies power to the VDD pin. And because this is a 4.0 series device, it doesn't need much power to operate. So there are 6 inputs all wired together, all being fed from the output of the PIA, and they alternate when one bank is high, the other's low, and vice versa. And it's only because of that lucky arrangement with the way these are being driven by the PIA that this circuit worked at all. It just happens that there is always a high input to one of these inputs to the gate, and that means there's always some power being bled off into the VDD pin, and that means there is enough power just about to drive the output, and then that can be detected by the input to the PIA via the multiplexers. So it's very strange that they've done that. I can only assume it's an oversight and they just forgot to put a track on there. I can't see any advantage to doing that. It makes for a very flaky circuit, and it's lucky it works at all. If you do have one of these and you're finding that keyboard behaviour is a bit erratic, then what I'd suggest is just putting a couple of link wires from the VDD pins on these two devices across to one of these and supplying power to them properly. Relying on this kind of parasitic powering of ICs is of course not intentional as far as I know, and it's not a good idea. I'm going to leave it like this. This is a repair, and I don't like modifying machines when they're not mine, and when I don't really have to. I like to leave them original, but that's just something to bear in mind if you do have one of these, or if you do purchase this machine. So what I'm going to do now is put the rest of it back together, clean it up, refit the battery, reassemble it. There's some work I need to do on the case, and then we'll have a look at the finished unit, and then that should be it for this project. Okay, I've got the Tiger reassembled, just the top cover to put on. I've given the bottom and top cover a good clean. I've still got a bit of tape residue to remove from the top cover. Unfortunately the tape that was used on this has left quite a lot of residue, so I'll try and get that cleaned off. Then it's just a case of refitting the top cover. It's come up quite nice and clean. I've made a few very minor modifications. The first one is I've put the connectors for the main 5V supply on the supply board rather than the main board. The main board, where the original connector was a bit too badly damaged to refit a connector. So I've done that. I've refitted the battery to the main board. It will still need configuring, and I've just got a bit more work to do on this. The two holes on this side of the power supply tray in the plastic case were stripped, so I need to fill those with epoxy and then re-drill them so I can put fresh screws in there. I've dug up a set of new screws I can use to hold the two parts of the case together. That's what the tape was doing when I got this, it was holding the two parts together. But it's all now working, it just needs the case reassembling, and that's this project done. Just have a... Okay, so that's the HH Tiger computer repair completed. It's up and running. I've cleaned the case to a certain degree. I'm not going to go overboard. This isn't a restoration, this is just a repair. But the case is in very good condition. Everything works, the LEDs all work, shift lock online, power works. Video output works. I've tested all the ports as far as I can without the drives and the proper monitor. We'll have a final look at the monitor just so you can see what's on screen at the moment. So as I mentioned previously, it's now waiting for a boot up disk. This isn't the proper monitor interface, as I also mentioned. This is just something I cobbled together, so the display quality is not very good, but it is working, and if you press enter, it will either reboot or it will go to the CP/M loading prompt, but of course CP/M won't load because I don't have the drive or the disk installed. But as I said, it is now working. I'll just give it a reboot, and as you can see, it starts up the way you'd expect. So that's it for the Tiger. Very interesting machine, and certainly a worthy addition to any collection. It's architecturally very interesting design for the time, or for any time really. It was one of those one-offs, extremely rare. Working examples extremely hard to come by. This is not my machine, but I'll leave a link in the comments as to who owns this. I believe he's going to be selling it, so if you do want to pick up a very rare piece of computer history, then get in touch with him. I don't think it will be around for very long.